So I will briefly introduce myself. My name is Viktorija Prilenska, and I'm a postdoctoral researcher at Teltech, and I'm involved in two projects, the GreenTwins project and the Wellbeing Score. And today I'm going to elaborate on the GreenTwins. And by the way, by the background, I am also an architect and planner, so if you have any questions related to that field, please ask. I'm the right person to answer. So the GreenTwins project focuses on the urban green digital twin. I don't know how familiar you are with the concept, but I think nowadays it's quite popular and quite well known. So what are the urban digital twins? These are basically containers for 3D models, data, and algorithms. So basically, this twin is much more than a 3D model. It also contains different semantic information about the buildings or traffic flows, or where does the population live, etc. And it integrates all this data together so that you can analyze and predict and build patterns based on this integrated data. And why we are interested in these digital twins is because it supports the stakeholder engagement, so you can take rational and informed decisions based on the data, and you can also combine this rational knowledge with some informal and tacit knowledge. Currently, as you know, Estonia has a few digital twins, so we are working in this direction. Estonia is probably the only country in the world, to the best of my knowledge, which is building the countrywide digital twin. I don't know the exact launch dates, but probably it has been already launched. I have to check that data again. So, this digital twin is built by the ministry, but also Tallinn has its own digital twin called Linnamoodle. And the project GreenTwins is focusing on this digital twin, so we are complementing the digital twin of Tallinn. So what are the aims of our project? Basically, there are two. We are building the layer of greenery for the digital twin of Tallinn. It's not going to be the whole city. For now, it's going to be only a part of the city, like the pilot area, but we intend to scale it up. And we are also providing some new tools as an interface between the data that we gather and we provide and the stakeholders. And also, we are aiming to strengthen smart and inclusive urban planning. So basically, our project consists of 3 parts. So the first part is a database, so basically the library of digital plants. Then the second one is the interface tool, which serves as an interface between these database and the stakeholders, called Virtual Green Planner. And we had a third thing, because it's important to include everybody, and not every person is technology savvy, and maybe people need interpersonal contact and physical presence. So we're actually building a physical space in the city center, and it already has the name Evelyn, so where different stakeholders come together for the discussions about the urban environment. So let's start with the digital plant library. So the plant library stores information about the trees and grassy areas in the city, and it also makes projections of growth and seasonal change. So basically, our layer is dynamic. It's not static. We're not only storing the data about the existing plants, but based on the environmental models, we predict how these plants are going to grow and how they are going to change with season. So how do we collect the data? We are also using machine learning algorithms, but first we use the drone images of the area from 2 different angles, and by means of the machine learning algorithm we are extracting the data about tree location, size and species. And the precision of our algorithm at the moment is between 70 and 80%, which is rather high. So you don't need to go on the spot and do all the laborious field work, but we get this collection of data automatically. But of course, we also, since it's work in progress, of course, we also validate our data with fieldwork inventories to improve the precision of the algorithm. And as I said, the innovation of this green layer is that we also make these projections. So we predict how the branches are going to elongate, how the trees are going to grow new branches. So if the tree is big enough, how these branches are going to bend because of the gravity, and how they're going to die. And here you can see the sample prediction. So you can see the 3 trees which were growing. Here they reached maximum growth, and here you have only 2 trees left because 1 tree died of the old age. So basically that's our aim, that's our ambition, and we are currently already quite far ahead with that. And what's the added value, then, you will ask, for the city models? And the thing is that having all this information, we can have scenarios. So we can do the benchmarking. Let's say this is the status quo scenario, so nothing built. So we can compare different scenarios. For example, what will happen when we will have dense urban development? What will happen if we will have loans, if we will have this loan converted into the meadow, and what will happen if we will let all this land to grow the forest. And we will be able also to make predictions of how diverse this environment is going to be, not only for us, for humans, aesthetically wise, but how different species like bumblebees or birds are going to feel in that area. Because I think we are currently trying to plan cities not only for people, but also we're trying to be inclusive and also to incorporate other species into the perspective. So the next tool, it's more of an interface, and it communicates with this plant library. So basically it's a 3D co-creation platform, a very simple one, where like a person which is not familiar with 3D modeling can also operate, and it allows you to create your own alternative plans, but also see plans which are created by other users, so everything in one environment. And you will be able, because these plans are created in one environment and have the same basis, you will be able to also make comparative analysis of these plans. So our ambition is to let the city, the developers, the city, but also regular citizens to contribute into that application by building their plans and compare their plans and discuss and share. So, and here you have some preliminary snapshots, and we are developing this application further. And I would say the heart of our project, or maybe the thing that most people will see and which will be most important for everybody, is the Smart City Planning Hub, something that we are already building, and we are already in the building construction tender process. So this is the space in the city center in Tallinn at Carlipo Este 1, which is equipped with the state-of-the-art visualization technology, and which allows and which facilitates the digitally aided public participation. So, and here you have already the preliminary screenshots or visualizations of that place. So the idea is that it is not a finished thing, but it's kind of a work in progress, something which gives you this workshop experience. So, and we have already tested that space in a pop-up event in March 2022. And we plan that we are going to have a grand opening in spring 2023, probably in March. So if you are interested, please come visit us, or also follow us on Facebook. I forgot to put here the link, but you can find us by the keywords GreenTwins project. Thank you very much for your attention.
Thank you very much, Viktorija. Ladies and gentlemen, do you have any questions? Oh,
yes,
we do.
Please.
2 questions. Let's start from the left side of the hall. May we have a microphone, please? We have a microphone. Thank you very much.
I was very interested in the ability of these drones to actually understand the plants and making forecasts. You were talking about it. You talked about birds. You talked about bees and how things look. What about carbon sequestration? That seems to me to be like a very big thing. Are you able to, or would you be able to use these models to, estimate the carbon sequestration impact of this? What are your plans for that? I know companies that are really interested in trying to do that.
Mm-hmm. Yeah, thank you very much for your question. So the carbon calculation, we have considered it, but currently it's not in the scope of our project because our project is quite short and we are more of a pilot project. So we're building the demos of the tools and we focus on getting the software and the hubs working. So the amount of analysis which we can build in this stage into these tools, it's quite limited. And we decided to stick to different biodiversity indicators. So these are indicators more related to flora biodiversity and also some impact on the fauna. But of course, CO2 can be also included. But this could be then included as an additional model. And why we decided to have CO2 maybe on the second place is because currently there is quite a lot of ongoing research on the CO2. And we think that maybe CO2 as an indicator is slightly overestimated. If we speak about environmental assessment, it is necessary to take into account the whole cycle. Also biodiversity, also material depletion, also different toxic emissions. So it's quite a complex assessment. So in the framework of the pilot project, with a limited time frame, we have to pick only things which are important for us. And in this project, we decided to focus on biodiversity, but maybe in the next project, we will be able to incorporate it as an additional module.
But theoretically, achieving climate neutrality, which is a big challenge for Estonian cities. If we look at Tallinn's climate strategy, I mean, you can clearly see that if we don't make a dramatic change, we cannot achieve the goals that we have set. So these kinds of models that you're preparing could be used to actually achieve these climate neutrality goals.
Well, yes. We are currently focusing on the city of Tallinn. Of course, these models can be scaled up, and that's where Estonia is going on with the countrywide digital twin. So purely theoretically, if you have the data about the whole country and information about the buildings and the traffic, of course, theoretically, it can be done. But I think building these models is a quite complex task, and very often, and what we encountered is the problem is not the data itself, it's not the model itself, we can build the model, but the availability of data. So how are we going to source the data? Do we need to do manual work? Or if we automate the data, how do I automate? Also, the big data has a lot of limitations, for example. If we're speaking also about drone images, we currently cannot locate, let's say, shrubs or grass areas with this data. So there are quite some limitations. But I think if we would like to achieve climate neutrality, the best way would be maybe to start with everyday habits. Don't take the elevator. Choose the product without plastic packaging, walk more, use car less. If you're at home, maybe don't turn your heating on maximum. Just put additional sweater, choose ecological materials, reduce maybe the consumption of the things that you don't need. Don't buy the latest cell phone, let's say.
But it would be so good to model it digitally and then provide people with the evidence, because I know walking is good for me, but I walk a lot more after I purchased a smart ring and I see the data in real time on my mobile. But ladies and gentlemen, I saw there was one more question, so go ahead.
Thank you for your
Yeah.
presentation. It was really nice. I have one question. Do you somehow think about using virtual reality for like visualizing your digital twin? I mean the virtual reality when you have alignment of the cameras and think like this.
Thank you. We do. If I will get my presentation back, I may show you the slide. Due to time limitations, I was not able to. I wanted to present all the tools that we are doing, so maybe I can elaborate here. So this is basically the technology that we are going to have installed in the hub. This is a screen, and we are using active shutter glasses. So it's not the virtual reality, I would say. I would say it's more augmented reality, and it's the technology the same as in 3D cinema. So you will be able to have an illusion of the three-dimensional picture of something. And why not, let's say, virtual glasses? Because when you are wearing the glasses, which fully cover your face, you are sort of separated from other people. Whereas other technology with this active, small shutter glasses, you can have a discussion over the screen and over this model. Here, basically, people, they are standing in half a circle. It's because they have this impression of a non-existent but virtual model in front of them. So, but basically you will be able to look at this model from different angles. You see the other person in front of you, and you will be able to discuss. But also answering your question about if we can model everything.
I'd like to.
Yeah, I don't know if we need to model everything. So because models are very resource demanding. And the question is, what is the purpose of our model?
Models are not good for climate, right?
I wouldn't say, no, don't take my words out of the context. I think if we build every model, we need to think what is the purpose. And if the resources that we input into that model, which is quite expensive, if they pay us back. Also, speaking about the data and modeling, it's not a very, it's a difficult question because data centers, they also consume a lot of electricity. They have huge land resources. So data centers, especially in the Netherlands, it's a big problem, and they even introduced a ban on building new data centers. So, I think soon we will also have this issue of data pollution and having too much data. So we would need to clean up. So data production is also another part of this consumerist culture, I would say. So probably we should model, but we should model wisely.
Let's go on a data diet, ladies and gentlemen, and a smart way of gathering data. Thank you very much, Viktorija, and applause, ladies and gentlemen.